Hello everyone. In today's lecture, we are going to learn about Numpy in Python. Now, Numpy is one of the most powerful numerical processing library, which is mostly used for performing mathematical operations. Now, whenever we talk about mathematics, then matrices are bound to come in picture. So, Numpy basically provides an extension package for multidimensional array. Now, multidimensional array includes vectors, matrices, tensors, which are all different dimensional arrays only. Now, another thing that stands it out is that it provides an efficient and convenient scientific computing. I'll show that through a code how it is efficient and how it is useful in just a minute. First, let's see how we create a simple array in NumPy. So this is an example I'm using. First, when I'm using NumPy, I need to import that library. So to import that, I use this command, import NumPy as np. Here as np means that whenever I want to use any function from this numpy library, then instead of writing the whole name numpy and then inside that the function which I want to use, instead of that, what I'll do, I'll make an abbreviation of that term. So here I'm making numpy as np. So whenever I want to call any function inside numpy, then I'll just use np dot that function name. So this is how we import the library numpy. Now here a is a variable which I want to initialize through as a numpy array. So np dot array and then bracket, and then inside that square bracket, and in that I'll give the elements of that array. So here I am giving 1 2 3 4. So this will give my variable a as a numpy array that is of length 4. So let's print this and see. So this is my output. This is my vector, or I should say one dimensional array. This is a. Now again I am making another array. I am printing another array, numpy array as np dot a range. So in list we studied about a function that is range, in which it makes a list of like if it is range of 10, then it will make a list of this 0 to 10, 0 to 9. Yeah. So here we are making, instead of making a list, we are making a numpy array. So this is how we are printing it. Now many of you may have a question that, okay, we are already aware of list, then why do we need to learn about numpy array if list is also equally capable of serving the purpose? So let's see this, how this numpy array makes our code efficient and why it is basically useful for us. So let's see this. So here I am making a list with L of range 1000. So this will make a list starting from number 0 till 999. Now I am making using a function that is time it, in which I want to get some information about how much time it is taking to computing things. So here what I am computing, that I am making a list from this list which will have all the values of the square of this list. Suppose this list is 0 1 2 3 till 999. So I want to make the element, I want to get the square of each element and then make a list of it. So this is I square, this is I double multiplication 2. This means that I ki power 2. So I square. Now I square for I in L. So I will go in each value, each element of this list and make the square of it, and then it will get the another list. So this is I am getting so from this I'll get how much time it takes to do this computation. Now again same thing I am doing with numpy array. So I am making np dot a range, and then again I want to get time it, here 8 power 2. Yeah. So let's run this. Yeah, so it is completed. So I can see that for this one, for the list one, the slowest run took 4.48 times longer than the fastest, This could mean that an intermediate result is being cached. 1000 loops have been done, best of 3, and 254 microsecond per loop. So let's just see the mean result, that on an average it is taking 254 microsecond per loop. So this is the computation time of when we are allocating memory in list. But when we are allocating memory in NumPy array, we can find that the average time of computation is 1.47 microsecond per loop. So can you see the difference? It is almost 200 times more than NumPy array. So this is how the memory allocation that is being done in NumPy array is so efficient that the computation power becomes very strong, and time reduces. So here we can see that just 1.47 microsecond is required to do the same operation. So let's see how to create arrays in different ways. Now, as I already told that arrays can be of 1 dimension, 2 dimension, 3 dimension. It can go up till n dimension. So generally, when we have an array of 1 dimension, we call it as a vector, and when we have a dimension 2 of an array, then matrix, and when we have 3 or more than 3 up till n, we can say that n dimensional array as tensor. So this is general nomenclature that we follow. Now if I want to initialize a 1D array, what shall I do? So a is equal to np.array, as I already told. With this round brackets, inside those round brackets we give square bracket, and that is the value in which I'll inside the square bracket only we'll give the elements value. So here I have given, so let's run this and see. Okay, so this is already done. Okay, so executed. Yeah, so here array 1 3 4. Similarly, when I want to make a 2-dimensional array, then inside the round bracket I'll make this will be my outer square bracket, see, and inside that I'll give kind of a list of list, you can say 1 2 3, this is in one square bracket, and 3 5 6, this is in another parenthesis. So these two parentheses shows that we have two different parenthesis set, and which means that we have 2D array. Let's see this. Let's print. Yeah, so here this is an array 1 2 3 and then 3 5 6. So we can say that it is a 2D array. And let's see what all can we get in this, like a.ndim. Ndim means that what is the dimension of that particular array. So a.ndim, from this I am getting that the value is 1. This means that the dimension is 1. So through this command we can get to know what is exactly the value the dimension of that array. Now a.shape gives me 3 comma, which means that it is just a 1-dimensional array of which has 3 elements. Another thing that I can do is length of a. Through this I will get to know that okay, there are 3 elements. Similarly, we can do this in this also. b.ndim, I should get 2. This is the 2-dimensional array. So you should be aware of how this bracket things is working and how we are making 2-dimensional array. We'll see the 3-dimensional array creation also. Now if I want to know the shape of this, then b.shape, it is 2 comma 3. So you can see that if we print b, then this is 1 2 3 3 5 6. So we have the 2 comma 3 here, means that see, this 2 means the number of rows, this 3 means number of columns. So whenever we want to get the shape of the array, then we do b.shape, and whatever result we get, that is the first entity means the row, the second is the column. Yeah. Now suppose we are having this 3-dimensional array C, in which, so how this is getting initialized, get a note of it, that this is my see. So let's first run and see how it comes. Yeah, so 0 comma 1 1 comma 2 2 comma 3 5 comma 6. So we can see that this is basically a three-dimensional array. This is my first page, this is my second page. So 0, 1, 1, 2, this is my first 2D matrix, and then behind the page there is another 2D matrix, that is 2, 3, 5, 6. So if I want to know the shape, then it should come 2, 2, 2. So it is just like a cube. You have to imagine this, how it is working basically. See, so in a cube we have a front face and a back face. So on the front face we have this matrix, and on the back face we have this matrix. Okay, now again if I want to know the dimension, so c dot end in, yeah, so this is three-dimensional. Okay, so this is how we create arrays. Now till now how we have created is that we have given each value uh, to all the elements basically. Now suppose I want to make a big array of which I know what pattern it follows, but I does not want to hard code it. I does not want to give each value to each element. So for such uh, arrays we have some functions to create them. So let's see them. So here we are using arange function. Now what is arange? We have already known that uh, whenever we want to make an array of which we know the starting entity and we know the last entity, and then we can use this arange function. So here I am making a arange, and this there is certain convention that this function follows, that it can take 3 input arguments, in which first argument stands for the start, means the start value, the start value, and the second is the end value, and the third one is the step function, like the step, how much step, how long the step should be, how big the step should be. So let's see this. Yeah, so here it is starting with 1. It is starting with 1, and we said that the last entity should be 10. So it is going up till 9 because we are giving a step of 2. So after 1 it will skip 2 and give 3 because the step is 2. Suppose if the step is 3, then it will skip 2 and 3 and will directly give 4. So 1, 4, 7. Yeah. So this is how it is working as an arange function. Now there is another function, a very useful function I should say, that this is using linspace function. Now what exactly do that? It is similar in a way to arange function, but instead of giving the steps, it gives the number of points. So we give the starting entity, the last entity through which it should end, and the number of points that should come between those two, start and end. Let's see this. So here I'm printing, I'm making an array whose starting entity is 0, end is 6, and in between it should be 7. So to make it more intuitive, I should make it as maybe this. Let's see. Yeah. So starting with 0, end entity 1, 0 to 1, in between or including them basically, it should have total 5 number of points. So first one is 0, then 0 0.25, 0 0.5, 0 0.75, then 1. So it basically have 5 entities, and starting from 0 and ending till 1. Now there are other common array functions that we can use, like while initializing a matrix. Suppose I want a complete 0 matrix, then I can do this np dot zeros. So remember to do this np dot, because all this function that we are using are basically inside this numpy library. So we have to call it initially. So np dot zeros, and then I'm using double bracket, because in that function argument I have to give a 3, 3 shape, which tells me which tells the program that what should be the size of the matrix that you want. So this is 3, 3. So suppose if I'll print this, yeah, so here I am getting this, C is 0, 0, 0, 0, 0. So all this a 3, 3 matrix of all the zeros basically. Yeah. And the next is using the function ones. this will give me the matrix with all the values as 1 inside it. So 2 comma 2 matrix I want to generate. So here it is, all the 1 values. And I stands for identity matrix, in which all the diagonal values are 1 and all other values that are non-diagonal, they are 0 basically. So n dot I, here I am making it a shape of 2 comma 3. Suppose I am making it 3. So this will generate a matrix of 3 cross 3 in which all the diagonal entities will be 1. Now in the case that I had earlier, that is 2 comma 3, in that I can see that it is trying to follow the diagonal only. So here 1, here 1, but not here, because the shape is 2 comma 3. So where till the point it is possible, it is trying its best to give all the 1s. So this is also the output of this I function, in which 1s are on the diagonals and 0s elsewhere. So this is the diagonal line and 1 value is given in the diagonal elements. Now there is another function, that is diag, which is again for making a diagonal matrix. Now let's see this. With this diag function, I am just giving a list basically. This list stands for the values which shall be included on all the diagonal elements. So here these are the diagonal elements. So I am giving the value 1, 2, 3. Suppose I am giving again 5 and 0. Then I'll print. So yeah, 1, 2, 3, 5, 0. So this taking as an input argument only the diagonal values, because it knows that all other entities will be 0 itself. Okay. Now next is, if I want to create a random array. So when we learn, or when we do neural networks in in artificial intelligence, then this is a very important task that mostly when we initialize weights basically, you'll get to know this, don't worry about that, but I'm just giving a brief introduction, in the sense that this random array is very useful in most of the programs. When we initialize weights, then we generally initialize it as a random value. So here, to initialize a random matrix, what we do, inside the Numpy package we call a random module, and in that random module we have a function that is rand. So through this, it generally generates a matrix of random values. So let's run this. Print A. Yeah, so I can see that all the values, they are basically from 0 to 1 and they are random values. So again, if I'll run this again, then I can see that value, all the values got changed, they are updated, they are again some random value. Okay, so next that we are going into is data types. What are data types in Numpy? Now when we make arrays, suppose in this example we see we are making an array, Numpy array basically, that is a range of 5. So we know that it is going from 0 to 4. So when I am printing this, a is this. Now I want to know what is the data type. So here a range 5, in this I know that the data type is integer, int 64. Suppose I want to explicitly specify the data type or enforce a data type in particular Numpy array that I am initializing, then in that I can do this, that when I am giving the input argument, with that I can tell the data type also. So d type is equal to float 64. So this will make my Numpy array of the same input parameter as of data type float. So you can see what is the difference here in both of them, that here we are having 0, 1, 2, 3, 4 that are these integers, and here we are having 0 point, 1 point, 2 point. So this is the difference. When we have this point, it shows that it is a float value, it is just showing it like the decimal nature of it. So this is how we can change also, and we can know also what the data type is of a particular NumPy array. Now there are other data types also, like we have this complex data types, or we have this Boolean data types. Let's see this also. So D is equal to np.array. So how I am initializing a NumPy array with data type of complex number? We can say that 1 plus 2j. Here NumPy, here this Python itself gets to know that this is the iota. This is serving as an iota in the complex number that we already know. So 1 plus 2j and 3 plus 2j. So 1 plus 2 iota plus comma 3 plus 2 iota. Yeah. And then I am printing this. So the data type I want to know. So this is giving me output as complex 128. So this is the name of this data type, the complex number. Then next I am making a NumPy array with the entities of true, false, and true. So we can see that this is the data type of Boolean. So bool. Yeah. Now we have got to know how to create, how to know the data types of any NumPy array. Now let's see how to slice, how to reach any particular index, update the value, and get a particular set of index or particular set of values in any particular NumPy array. To do that, we have slicing and indexing. So let's first see about indexing. So here I am making a NumPy array, or I should say matrix. So this is a NumPy matrix because it will be a two-dimensional array, as we are using a diag function, that is a diagonal function that generates a diagonal matrix with all these values in the diagonal elements. So let's run this first. Sorry, I should print a. Let's see. Yeah, so 1 2 3 4, these are all the diagonal elements that are being filled with this list. Now in this NumPy array, this is a two-dimensional NumPy array. I want to access a particular element in that two-dimensional NumPy array. So similarly, as we have done in list also, we'll just give the index of that value. Suppose I want to know this. So what will be this index? 0 1 2. So 2 comma 2. So it will, let's print this 2 comma 2. So yeah, it has given me the value 3. Suppose I want to update this value. So after reaching that value, I can update also that a2 comma 2 is equal to 5. I have updated it. Now if again I'll print this matrix, then I got that this is 3 is being updated and it is implemented here. So this is how we access any element in the NumPy arrays. Now let's see how to do slicing in NumPy. So here I am having a is equal to np.arange. I am again making a NumPy array starting from 0 till the ninth value, 9, 0 to 9. I am printing this a, and then I am making a slice. Now as we have seen earlier, this slicing we are already aware of, because this is kind of the same convention that we follow in lists too. But why we are using NumPy array, that I have already explained, and then more intuitiveness you will get through the course when you do programming more and more. Yeah, so a 1 5 2, what are these number exactly? So it is the start index, end index not included. This is important, the end index is not included, and then step. As so are you aware of this? You must be aware of this, that when we use this in Python, that index starts from 0. So whenever we tell any length of or anything, or not length, basically when we tell the index, the end index, then it generally refers to the one before that index. So the end index is just basically not included here, and this is the step. So 1 to 5 and 2. So 1 will be the index. What will be the index 1? Here this is 0, this is 1. So this is the first index. Then 5, and this is not included, so it will go up till 4. 0 1 2 3 4, because end index is not included. So 1 and 4, till starting from 1 till 4, and then the step size is 2. So starting from 1 it will include 1, then step size will 2, it will skip 2 and it will go to 3. So 3, then it will skip 4, but 4 is the last index, so it will stop there. So 1 comma 3. So this is how we got the slice from this numpy array. Okay. So this is it with the basics of numpy. Thank you.